Alright, so a little bit of searching and me determining what the optimal format is. Like, should I use RGBA or BGRA? It doesn't matter because looking at this chart for WebGL2, you notice that all of the RGBA integer types are RGBA. There's no BGR and then A. So as far as like trying to optimize the pixel packing and unpacking by using a format that the GPU most prefers, it's not even an option for what I'm trying to do, because I want to have all of the pixels. Because I'm using the texture as data, right? And so I want to carefully bitpack each pixel with binary data. So I chose to use RGBA integer, and these are the only formats here, these unsigned integer formats right here, that are going to allow me to do that bitpacking stuff, and they're all RGBA. So I don't get a choice at which format I want to use. So even thinking about optimizing that, it doesn't even matter. And with that, I'm going to I have a little project I was working on for how I think I'm going to set uniforms to my shader, and I'm going to use like a big texture that will be used to act as uniforms, and we'll just push up the texture after we've updated a whole bunch of values. Because I guess GL text image can be pretty fast, but it's definitely not something you want to use on just one pixel. But if we can update all the values that we want to use as uniforms and then push them up all at once in a GL text image call, we could get some good performance, I think. So let's see, where is that? It was uniform manager to, let's see if that works. Nope. Okay, so let me go find that. Uniform manager. Okay, so I'm just looking at my shortcuts here. Okay, and paste. Okay, so this code is not complete. It is a general idea of how I'm going to do this, and some of the areas haven't been filled out. But what I'm going to do is I'm going to have constants that are some type of integer value. They're going to actually be like enumeration. So, you're going to say this one's 1, this one's 2, this is 3, and these values are going to indicate index positions within a texture, right? So if it's a 512 by 512 texture, you have, what is 512 times 512, like 1048? Hold on, so 512 times 512. Okay, so 512 times 512, that's 262,144. Let's use something smaller. So let's say you have a 4x4 texture, right? 4 pixels by 4 pixels, right? Well, 4 times 4 is 16, so that means you have indices 0 through 15, right? 16 minus 1. And so for these enums, you could go all the way up to 15, right? You could actually start at 0 here. And then you can use these enums to access an indexed position within that texture, right? So coordinates within your texture can be defined by an index or by an x and y coordinate. Because we want to keep like a list of all these different variables that we want to pack into a texture, we're going to use the index location, so we can just count sequentially through all of the possible locations on that texture. Where that ends up physically being on the texture depends on how we've decided the size of the texture will be, like the rectangular region, right? So if it's a square texture, right, that's going to change. If it's a big square texture, that's going to change where it is. Like if it's a 512 by 512 texture and you have these 16 slots, they'll be all on the same top line of that texture, right? Because it doesn't need to wrap around yet. Whereas if this was 16 and 16, right? So a 16 by 16 texture, then if you use values 0 to 15 for all the different enumerations, they would have to wrap around that texture, right? Because they would fill the whole texture space. But we don't really care exactly where these values are. We just care that we can confidently put them somewhere on the GPU and confidently fetch them back. So if we take these values and we put these values on the CPU, and then we also hardcode these values into the GPU, we can do the correct math to get them back out. And you'll notice that I have TU01. This is because TU is for texture as uniform, so we're going to use a texture like as if it were a uniform, and 01 is just a number, right? Because I might have more of these. And if we go, oh wait, not in this code, but if we go look at our comments way down here, so far these are the different ways that I'm thinking of partitioning up a 512 by 512 chunk of pixels. And the options for creating a texture as a uniform, we could use an 8 by 8 pixel chunk, or a 16 by 16 pixel chunk, or a 32 by 32, etc. And so we have to decide. So we could call these like little plots of land, and we gotta decide, you know, what little plot of land in GPU land are we going to claim for a certain set of uniforms that are encoded into the texture. So if we're never going to exceed 16, then we can just, you know, choose one of these 4 plots. If well, what's 16 times 16? 16 times 16. Okay, 16 times 16, 256. So if we know we're not going to exceed 256, we could choose this plot, and this plot, right? And we don't want to use a plot that's way bigger than what we think we're going to end up using, right? So, you know, we probably don't want to use, well, this is actually what this is packed into. So this is not actually a plot. Right, if it says above, then it's a plot, because this is actually this thing right here, right? I don't know if that made sense. But yeah, now let's say we decide to map everything to over here, and then eventually we will run out of room. We run out of all of our 64 uniforms that are within this 8 by 8 texture. Well, we should try to make it so it's not too hard to do a slight amount of refactoring to just move it over to another chunk here. Now, we are working with a limited amount of memory. Like, we got a decent big chunks of memory to work with, but space is limited. But like I said, I think that from what I learned in art school is that constraints can help you make better designs, right? Because if you think about a design that contains all possibilities all at once, that's called chaos. That's called entropy. That's called the heat death of the universe, right? You have to have some type of constraints. You can think of like a sculpture as, right? You can think of a sculpture, instead of like thinking of a sculpture as adding things, you could think of it as taking things away. Like a big block of marble, that's all possible sculptures all at once, right? Just a big rectangle. And then as you chisel away to make a figure, right, it's like you're adding constraints. You're saying, no, I'm not going to allow any material to be here. I'm not going to allow any material to be here. And you're constraining the parameters of that that prism, and that's what makes it the art, if that makes sense. unless you like really super modern art and you're like, oh, the prism, that is the art. But I'm talking about like making some type of like classical sculpture, or making any type of useful art that isn't your bullshit high art. Convince people you're smart so that rich people will give you money art. I'm talking about art that actually has some actual skill in it. Yeah, shots fired. I'm not talking sticking bananas to a wall or some other bullshit. So yeah, when I say I went to art school, I went to I went to DigiPen. So we did art specifically for video games. So it wasn't like, right. I think there's different kinds of artists, right? And if you're an artist for a video game, you are you are more of an artist of merits, not an artist of I think like a crazy person and do a whole bunch of weird shit. Not to say that just because you, not to say that I'm not weird, but to say that if you do art for an industry, you're probably more grounded in reality and skill than some of those fine artists. And fine artists tend not to like computers, so hopefully none of them see me trash talking them right now. But if they do, come fight me. I don't know what to tell you. Okay, so I'm gonna stop recording, and then we are going to get into flushing this out as well as explaining it. Okay, later.